And welcome to Math with Miss V, creating sample spaces. In previous videos, we looked at the probability of simple events, the difference between theoretical and experimental probability, and how to make predictions. These were all related because they all dealt with simple events. In this video, we will define compound probability, and we'll look at how to find it using a sample space. We are focusing on standard 43, ST 8B, represents sample spaces using tree diagrams list to identify the outcomes in the sample space which compose the event. So a compound event is two or more simple events happening at the same time. For example, flipping two coins, or flipping the same coin twice, rolling a dice and flipping a coin, or choosing a random number 1 through 10 and a letter A through E. The sample space is simply a list of all possible outcomes for an event or events. The two types we will look at are a tree diagram and an organized list. A tree diagram is a branching diagram used to show the total possible outcomes of compound events. These are very good for 3 or more events with a small number of outcomes each. An organized list is a manner of listing all possible outcomes for compound events. This is good for 2 events with a large number of outcomes each. So let's just jump in. We will do 3 examples, each as a tree diagram and an organized list, so you can get a feel for which one works better in what situation. And then we will make a prediction, find the probability of a certain event. So the first one is a tree diagram of rolling a dice and flipping a coin. So we want to start by listing all of the outcomes for our first event. And so for rolling a dice, that is 6 different outcomes, the numbers 1 through 6. So I'm going to list them all here. Now we look at our second event, which is flipping a coin. And with a tree diagram, it is special because we draw branches off to show the 2 different paths it could take. We could roll a 1 and the coin could land on heads, or the coin could land on tails. The branches show the outcomes. And we're going to do that for each of our 6 numbers. And then the final step is just to jot down what the actual outcome is. So for our first one, we could get a 1 in a heads or a 1 in a tails. 2 heads, 2 tails. 3 heads, 3 tails, and so on and so forth. And the section that I wrote last, this is our actual sample space. It lists all of the possible outcomes for a set of events. The organized list is a bit different. I'm going to start the same way by listing all of my outcomes for my dice, and then we'll move to the coin. Okay, now I could get a 1 and a heads, or I can get a 1 and a tails. I could get the 2 with the heads and the 2 with the tails. 3 heads, 3 tails. 4 heads, 4 tails. 5 heads, 5 tails. 6 heads, 6 tails. And the nice thing about an organized list is that it's already my sample space. So I don't have to do anything else once I finish going through all of the events. So now I want to know the probability of getting a heads and a 5. So I can see in my tree diagram, if I follow the branches, I have one outcome that is a 5 with a heads. And I can also see in my organized list, I have one outcome that's a 5 and a heads. So I have one outcome out of how many in total? Well, if I look here, I see 2, 4, 6, 8, 10, 12. So I have 1 out of 12 outcomes is a heads with a 5. So that's just an overall difference between the two. I personally prefer the organized list. It gets me straight to my sample space. Some people might prefer the tree diagram because it can show you all the branching out possibilities. Let's look at our next example, rolling 2 dice. Okay, so we know each dice has an outcome of 1 through 6. I'm going to do 1, 2, 3, 4, 5, 6. And then I'm going to draw my branches. But this time, rather than 2 branches, I have to draw enough branches for 1 through 6 again. Okay, so I like to sometimes draw my numbers and draw my branches to them. And as you can see, this actually gets to be quite large. And due to organization in space, I'm not going to put all of these down. It's going to get very messy. And as you can see, I'm already overlapping my space from my 2 tree into my 3 tree. So I'm going to skip to my organized list. So I know I'm going to pair 1 with 1, 1 with 2, 1 with 3, 1 with 4, 1 with 5, 1 with 6. And I'm going to pair 2 and 1, 2 and 2, 2 and 3, 4, 5, 6, and so on throughout all my numbers. Okay, so you saw it skip forward so that I have all of my outcomes. And so you can see, even with an organized list, it works. It still takes a while to write out. This would be faster if I was more organized because I don't have to write my first event 6 times. I only have to write it once, and then each one has the 6 branches. But tree diagrams is not my branch of math I'm the best at. I understand them, I can teach them, but drawing them is not really something I'm very good at. So I'm going to use my organized list to find what we're looking for the probability of, and that's the probability of double 3s, 3s twice. So I'm going to go to my 3 row because I need 2 3s. I'm going to see I only have 1 option here. Out of how many total? Well, this is an array, and we know we can find the space inside of array by multiplying. So I have 6 times 6. So I have 36 outcomes, but only 1 matched what I needed. Okay, we're going to look at one last example. So this is a spinner with 4 sections, flipping a coin and choosing a card A or B. So with our tree diagram, we're going to write down our 4 sections. I'm just going to choose numbers 1, 2, 3, and 4. Next is flipping a coin. So I'm going to draw 2 branches off for heads and tails. And then next is choosing a card A or B. So I need to now draw branches off each of my coin flip outcomes and show card A or card B. And then the final part would be to fill in my sample space, which is to follow the branches and give what the actual outcome for each one is. So for my 1 tree, I have 1 HA, 1 HB, 1 TA, 1 TB, and so on and so forth. Okay, so here are all of my tree diagrams for this set of 3 events. And I'm just going to organize this just a smidge. So as you can tell, there's a lot going on here, but we can easily see that we have 3 sets of branches. Now for my organized list, it would start out the same. But this time I would have to think through. I could have a 1 and an H and a 1 with a T, and a 2 with an H and a 2 with a T, and a 3 with an H and a 3 with a T, and a 4 with an H and a 4 with a T. And this is where the organized list starts having trouble with multiple things going on, because then I have to do my A or a B. So I can have 1HA, and then I have to think, well, I can have 1HB. I can have 1TA, 1TB, 2HA, 2HB, 2TA, 2TB, 3HA, 3HB, 3TA, 3TB, 4HA, 4HB, and 4TA and 4TB. So if it was more than what few things we have, it would be very hard to keep track of what I've named and what I haven't. So in this case, even though it doesn't look great, the tree diagram is better for listing out all of your possible outcomes. So now I want to know, out of any section, the chance of getting a heads and A. So we're going to look through all of our sections and see which ones are heads with A. So I can see 1 here, a 1 heads A, a 2 heads A, a 3 heads A, and a 4 heads A. And it corresponds with our organized list here. So I can see I have 1, 2, 3, 4 outcomes that follow the requirements of any section, 1, 2, 3, and 4, having a heads and an A, out of how many total possible? Well, I have 4 for each number. There are 4 numbers, so that's 16 possible outcomes, which gives me a 1 in 4 chance. Thanks for tuning in this Math with Me video. I look forward to seeing you in the future.